In some of the comments of the earlier video and social media post, people had some great discussions. One of the things brought up was that test-driven development and how tests are part of good code. I like test-driven development as it's a requirements-first way to create software. Requirements engineering was one of the focuses of my master's project, so I have some experience on the topic. This topic originally started off as a script to follow up short, but then I passed 500 words and thought it would be more fun to make this short follow-up video to give test-driven development some space to breathe. For this video, I'll be calling test-driven development TDD for brevity. TDD can be broken down into three main steps. First, define the requirement for a feature. Requirements define the expected set of behavior, and we'll get into an example of this shortly. Second, we need to create tests that stand for all the parts of these requirements and represent every aspect of them. That's the test part of test-driven development. And finally, we can write some code to satisfy these tests. We can then iterate on the code until it passes the tests. Then, once our code is passing the tests, we know that our code satisfies the original requirements as the test we made based on these requirements. An example of where I use this to solve a bug in my OpenKCC project was an issue brought up by Alex with the handle SanielX on GitHub, along with a suggested fix. The issue is that the player would start to jitter when running into a wide corner. I verified the issue, and with their help, and wrote up some requirements. The scenario is when the player walks into a wide corner, they should not slide backwards along the other wall from back before where they started. So, in order to verify how this bug is happening, and more importantly how to fix it in code, we have to use two main steps. First, we project the player's actual movement onto a line of their intended direction. This gives us how far they moved along the original direction, but does not tell us if they move forward or backward. To check if the player moved forward or backwards, we then take the dot product of that projected vector and the original intended vector and check if the value is greater than 0. If the value is greater than 0, then the player is moving in the intended direction. If the value is less than 0, then the player is moving in the opposite direction. So, I set up some tests with the scenario of a wide angle in mind and checked if the player moved opposite to the intended direction using the method defined earlier. I created multiple scenarios of the player running into walls at different angles, but the basic idea is that we want to ensure that the player, when moving forward, will not bounce backward and move beyond the corner along the other wall. That's what causes the jittery motion that we saw earlier. At first, these tests failed because we hadn't adjusted our original behavior yet, and this is the expected outcome. In the original code, all we need to do is add a simple check if the dot product between each individual bounce and the original movement is less than 0. If this dot is less than 0, it means we are moving in the opposite direction than the player's original intended movement. In this scenario, we can assume the player has bounced off something and is now moving backwards, causing that jitter we saw earlier. To avoid the jitter, we simply need to stop the player's movement whenever they would move backwards. Adding this check now stops the player when they would have otherwise bounced backwards before. Great! And if we run it against our other tests we defined earlier, we see that they should pass. And since these tests are automated, I will know in the future if these tests break at some point and the behavior regresses. This method of fixing bugs follows the test-driven develop method. We first define the requirement of how we want to fix the bug, then we created some tests to find and identify this issue and automated them to make sure we can easily run them in the future, and finally, we adjusted the code to pass the tests. Since we defined our test based on the requirements, we can be assured that our code now satisfies those original requirements. You can use test-driven development to make new features as well as bug fixes. The reason this is considered requirements-first development is because the test defines our requirements. If our code passes the test, then we can verify that our code satisfies the original requirements. The reaction and feedback to my last video about why you should test games has been great. This video, as well as a few of the shorts I'm working on, are all because of that great discussion I've had with you in the comments and on the Reddit about the videos. I hosted a small poll on my YouTube community page about what video I should make next. It seems like the multiplayer game dev one, and I'm already working on that script, so hopefully it'll be out in the next week or two. Don't worry if you voted for something else though. All these topics will be coming up shortly over the next few months. Have a great day!